Oh, oh God. Okay. Let's see. I guess we'll do this. Oh gosh, that's gonna sound so bad. Why won't you stay the way you were supposed to? Okay, whatever. We'll keep it like this, I guess. Hello. We're back. Um, so I did kind of work on it off stream, and we got a solid basis. I guess I'll show you guys what I have so far. Yeah. So let's run the game launcher. So let's see. I gotta adjust a couple things. You know what? Maybe it's not good for me to have this there. Oh well. I really hope the audio quality is okay. Because I won't know. Anyways, so far we've implemented some of the arguments here. So if I want to play a double 12 or a double 9 game, well, let's say I do 12. How many human players? Right now I haven't made the computer side of it, the CPUs. I'm going to do that I'm going to do that tonight during the stream. And so yeah, so if I select 2 and I want 0 computer players, we get this. And so we have the game state, which shows, player 1, and it has the random draw. And since we're playing with 12s and only 2 people, we should have 16 dominoes per person. If we count these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And so see, we got that working there. Same thing with player 2. We have the center. It's because we're working with 12s. It's going to have the double 12. And then the boneyard will have the remaining dominoes that we have yet to use, and they are listed in alphabetical, or not, or well, numerically. So if we want to, let's just say for consistency's sake, we just want to draw from the boneyard. It then goes to player 2's turn, and let's say player 2 wants to play a domino. Does player 2 have a 12? He does. Okay, so we'll hit P, which domino. So right now it works off of the basic. Well, it starts with 0. So this will be 0 and this will be 1. So we're gonna choose number 1, the first domino in our set. Which train? So technically, since we're player 2 and the trains have not been set up for player 1 yet, we can't play on player 1. So we're going to have to select our own train. We're going to start our own train. We hit 2. And do we want to flip it? Well, we're going to have to flip it because the left side is 0, and we need the left side to match up with the right side of the center. So in this case, we're going to flip it. And so we will say yes. And then from there, now we have in the train section for ours, 12 and 0. And it's player 1's turn. Does he have a 0? We have a 0 here at 0, 1, 2, 3 at the 3rd position. So let's play that. 0, 1, 2, 3, yeah. So let's play a domino. And this time we don't have to rotate it. We're going to say the 3rd domino on the list. And since we're on player 2's, we can play it on player 2. And we do not want to flip this. And let's say player 2, we draw. And so there we go. Now for player 2's train, we have it working. I have yet to add the conditions to check whether this is a valid placement, but we will be doing all that today. And then if I want to hit Q to quit, a simple system.exit with error code 0. There we go. And so yeah, so I did the whole human, the logic, at least for what I know so far. Again, I need to add the is playable, and I'm working on that right now. So in the domino section, we have this method is playable. You know what? I'm actually curious how to increase. Okay. I'm trying to figure out new ways for my mic to be placed, and it's just not working out. How to, I guess, increase size of text in IntelliJ, because I want you guys to be able to see this, and it would be pretty bad if you guys can't. So to change the font size, settings, editor, general. And then general. Okay, I think I should be able to find it here. In the dialog box, and check the item labeled change font size. In the dialog box. Is it editor tab, smart keys? Oh, I seen it. Font. I guess we could just increase the size by double. Let's see what happens if we do 20. Oh, that's massive. I guess we'll do that. Okay. That is a lot bigger. Okay. So hopefully that works for you guys to see better. So yeah, so we're gonna work on this is playable. And so I guess the goal of what I wanted to do, we're gonna be giving it a domino train. So I guess since I intend for this to be train, I will label this as train. Yeah. Train D. Okay, and we have this size, right? And we'll have an if statement. And basically what I want to do is, if the train size is 0, then it is, well, okay, so I already have an implementation in the human area to determine if it is of its own, so I don't really need that. So what I wanted to do is I want to go through the list, or I want to find the last one and do if statements on them. So we'll have a series of if statements in this case, and we're going to get the last in the train because we're going to be determining if the right side is the correct one. So if train D, the domino train that we're going to be taking in, and we're going to be getting the index, and in this case we're going to be doing size -1, and the reason why I say size -1 is because what I want to get is the last domino, and we're going to get the last domino, and then we're going to get its right side, which is N2, and we're going to say if this is equal to, I guess I also need to take in the domino in question. So yeah, so I want to take in the domino as well. compare D, that is going to be the compare domino. So if the last domino in the train, in the aforementioned train that we want to place it in, if the right number is equal to the domino that we want to place currently, our domino's left number, so compare D's N1, if this falls true, then we can return true because we have established that this is a playable, it's a playable motion, I guess that's what I want to say. Otherwise it's false. However, there is also the condition of doubles. So here, playing a double, when you play a double, you must also play an additional tile that is not a double, unless the double is your last domino, in which case the round ends. You can play the additional tile either on the double or on another eligible train. If you do not have an additional tile to play, draw a tile and play it if you can. If you can't play the additional tile, place your marker on your personal train. Alright. So just out of this, I know I need to do a couple more things as well. But we have this is playable function, which is going to determine if we can play our domino. So far in our code, if we were to go through this, and this is just the human side, again, we still need to implement the computer stuff, and hopefully, well, the CPU should just be a lot easier because it's just iterating. We should just be able to iterate through it. We're not going to make something completely complex to where we're going to make it smart and beat it. Actually, I guess I'll put on music. Shoot. Oh my gosh, that's going through the wrong thing. There we go. Alright. Anyways, what was I saying? So, fuck. Alright, so yeah, if we were to go through this as a human, right? We display the person's turn, you know, what they want to do. If they decide to play a domino, we have this in place where we get the domino and which domino we use. We then get that selected domino. This selected domino is very important because we're going to be using this. And then we also have the train. And so the train is going to seem a bit complicated with the way I did it. I guess I could have assigned it to a variable, but anyways, what I have here is we parse, because obviously we're going to want to grab the integer, so we parse it, and we -1 because since we're giving this UI design 1, 2, 3, 4, that's not actually what we're saying. For if they enter 1, we're technically getting the 0th position in the array, so that's why I subtract 1. And so this basically determines if this is a computer's train, because the way that it's set up, we're going to be displaying the players first, then the computers. So that would make it a lot easier to determine everyone's role. And so basically I say if this is less than the number of players. So this statement in itself checks if this is actually, if we're playing within the rules of the game, because we can only have up to 4 players. So in this statement alone, we're saying, is this even a valid move? And if this is greater than the human player size. So not only does it need to be, let's say we have 4 players and we choose train 3 and we only have 2 human players and 1 computer, then this should occupy this area. So if we choose 3, 3 minus 1 is 2, and that's less than the number of players that we have, which is true. We have the number of players being 3. 2 is less than 3, and if it's greater than the number of human players, And so technically, number of human players is set to 2, or human size. Greater than a human player. Yeah. If it's greater than the size, and the size is determined, so if we have 2, oh, okay, I see a flaw here. So if we have 2, then that means the size of it is going to be 2. And so we need to take the size minus 1. So that way this would be 1. And in this case, since we click 3, 3 minus 1 is 2. 2 is greater than 1. Okay. So then I gotta make that change with this as well. Minus the size. Okay. And so yeah. So that's what this does. And then we have our if statement, which checks if the train is valid. So, so we need to select a train. And so say we select train 1. However, the rules dictate that in order to play on a train, either it needs to be, if you're playing on other player's train, it needs to be filled in. But if there's no trains that is not your own, that's not filled in, then you have to play on your own, even if yours is empty, because you got to start the train. So that's what this check train at least in the check train computer, whatever. Basically what this does is we determine if the train in question is empty. And so if the train in question is empty and the train that we want to place it is the exact same train that is on our player. So say I'm player 1 and I want to place it on player 1's train. I'm player 1 and that's player 1's train. We're the same, it's my train. So that's what this determines if it's not equal. So that's what this does. So this statement here determines if this is my train. However, if it's not my train and it is empty, or if it's empty and it's not my train, either way, the train is not open and they can't play it. That's basically what this does. Otherwise, we're going to return true, meaning that we've determined either A, we can play it on someone else's train because they have a domino placed, or B, we can place it on our train because no one else has placed any trains or any dominoes on theirs. And so we use that. Simple. Well, not really simple. It's very complicated if you're getting into the logic of it. But yeah. And then here, if this is false, then that means we need to restart the input because we cannot make any valid plays here. Otherwise, we're going to go through this and we're going to ask the player, in this case, with human, do they want to flip it? Because remember, say you have a domino that's left side 0, right side 9. However, they want to place it on a train with the right side of the train's domino being 9 because they have to match it up and they need to flip it. That's what this does. So we determine whether what they say is true. If it is yes, then what we're going to do, instead of just saying if the left side, if the right side of the train domino is equal to the right side of the person's domino that they want to place, what we're going to do is we're going to reassign it because essentially we're flipping them. So we're going to flip the values as well assigned in our domino object. And so that's what we do here, because this will make it a lot easier for us later on when we add this to the train, to the player's train, because then the values don't get scrambled. And so that's what we do. We flip the numbers and then we add our selected domino that we've determined prior onto their train. So we take the selected train, which is, where did I define that? I defined that right here. The selected train, and that's different based on if it's a computer train or a human train. And then from there, what we do is we remove the domino from the player's hand. If it's no and we don't want to flip it, then we're going to add it. But this sequence right here doesn't actually show that if it's a valid move or not. And so that's what this all leads up to. is this is playable function in our domino object. We're gonna give it the train in question, and we're gonna give it the domino to compare. And we take the size, and we basically determine if the right side is going to be equal to the left side. So with that in mind, we can neatly put this right in here. So right before after we flop the values, we're then going to issue the check. So if what is it? Domino is playable. I think I could just call it, or I'm pretty sure what it's gonna have me do is, fuck, I'm gonna have to change this to a static again. So sometimes I have to change it to a static, but I'm pretty sure this would be okay. So yeah, so is playable, and we're gonna give it our selected train, and then our selected domino. And if these conditions hold true, and this returns a true statement, then what we can do here is the simple add train, and we determine that it's a playable function. Otherwise, we're going to do, what is it? We're going to say, what is it? We're going to just say non-playable domino. And we're gonna just restart the system. So we'll restart the method, because obviously we need the player to make a move. And so yeah, simple as that. From there we just we do the same thing. Let's see here. Yeah, I think I could just do this. Copy here, and paste that there. Bada bing, bada boom. And yeah, so we do that there, and then we do the same thing with this. Take this. If the selected train is in question, if this is true, otherwise we will do this. And that's for no. Take this and we replace this like that. All right, and I just need to make sure I have everything. Yeah, human players, computer player. All right, so now I don't need to check this. I'm pretty sure it works, but we have that functionality. Now we can determine if it is an eligible move or not. So now I guess the next thing that we should do is doubles. So I guess I'll read this statement again. When you play a double, you must also play an additional tile that's not a double, unless the double is your last domino, in which case the round ends. You can play the additional tile either on the double or on another eligible train. So, and if you have an additional tile to play, draw, or if you do not have an additional tile to play, then you draw the tile and play it if you can. And if you can't play the additional tile, place your marker. So we'll be implementing this right now, I guess. So what do we need? We need to, if it is a double, if we're playing a double, we need to then initiate a sequence of events that allows us to then play another hand. If we do not have another hand, then we need to also offer the option of drawing. And when we draw, we also need to be able to determine, can we play this? Again, this is the human side, so it should be pretty easy. When we get to the creating of the CPU or the computer player, it's going to be a bit more logical based. But for right now, this should be pretty simple. So what do we need? I hate having these two if statements dictate whether if it's a human train or computer train. I guess I could have technically redesigned this a bit better, but It's just too much work at that point. But we're going to keep pressing forward. So first things first. We determine the domino. We determine the selected domino. And what we want, what we'll need is on top of here, we will have a boolean. And we will say double. Well, we can't say double. We can't say is double. And we'll set that to a false statement for now. So what we're going to do is we're going to take the selected domino in question, and we're going to say if the domino in question, the selected domino's n1, is equal to its, well, technically n1 is its left side, n2 is its right. So if it's equal to, so if they are both equal, then we can say without a doubt that is double is true. So we set it to true. And so yeah. And otherwise it's going to be remaining false, so we don't really need an else statement there. So now we have a condition. Now we have the condition if it's a double. So now we'll go on the mindset that it is a double, and we'll go through this. I guess what we can do here, if we pass the train check, right? If we pass the check for the train, then what we can do is yeah, okay. I see how we can do this. Okay. So if it's a double, then we don't need to flip it. Simple as that. So I think what we can do here is else if is double is equal to true, then we know that we're dealing with a double, and so we can activate a sequence of events that will allow us to do the doubles rule. So what do we know? When you play a double, you must also play an additional tile. So we haven't played this double yet. So what we want to do, because we've already asked the player which train, so what we want to do is these right here. Yes. Yeah. So we'll take this, and we're just gonna move that there. So if the domino is a playable domino on the selected train, and the selected domino, and we determine our selected train here, and our selected domino up top, we already are assuming it's a double, or at this point we know it's a double based on this code. We're then going to then add the selected train, or the selected domino to the train. We're then going to remove it from the hand, and then what we're going to do is we're going to restart the whatchamacallit. We're gonna restart it. Maybe I should be doing this on the human part. I'm gonna switch this over to the human part. Yeah, it'd just be much more easier to do. Okay. So I guess for right now I'm gonna get rid of this, because with the computers it's gonna be a bit more difficult than just this. Yeah, so that looks okay. All right, and then we gotta change this to HM players, and then yeah, okay. So, what was I talking about? Okay, so if it is a double, and if it is playable, we're gonna add it to the tray, we're gonna remove it, and then we're going to reinitiate. We're gonna reinitiate this method. Technically recursing it within itself, and I think it should be fine. But yeah, so then what this is going to do, we haven't implemented the count. Oh yeah, no, this should work perfect actually, because then we will say before we launch it again, where I put it. God damn it. Okay. There it is. Before we launch this, we're going to say, just so that we can determine this, we're going to say, what do we want to say? Double was played. Play another domino. There we go. That's not a double. So yeah. So this should work. Let's give it a test. Alright, so we're gonna do draw 12, we're gonna have 2 human players, 0 computers. Alright, there we go. Do we have anything, do we have any 12s? Because that's what I want to get done first. Alright, so we have something here. So 0, 0, 1, 2, 3, 4, 5, 6. Okay, now we can do 6. We'll do 6. So we'll play a domino. We'll say domino 6. We are going to put it on our own train, and we're going to flip it. Okay, so now I'm getting this. Okay, so maybe it is a good thing I tested it, because now we're dealing with something with our is playable. Oh, I know what I'm getting. Oh, oops. I'm going to need another statement. If the size is equal to 0, then we know that it is playable, and we're going to return true. Alright. Small hiccup, we relaunch it. Alright, we go 12, 2 humans, 0 computers. What do we got here? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Domino 13. And we place on train 1. And do we want to flip? Yes, because I think I've seen that we need to flip. Alright, cool. And then for player 2, we're just gonna... Do we have any double zeros? Because if we do, that would be sick. Oh, player 1 has double zeros. Okay, so then what we could do here is we'll just draw for player 2. And then our double zero lies 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Domino 11. So we're going to play domino 11 on train 1. Double was played, play another domino. Boom, baby. So then we played 0. So I guess we can play another 0. Do we have another 0? 0, 1, 2, 3, 4, 5, 6. So domino 6. Or actually, in this case, I'll just draw from the boneyard. And then it's player's 2 turn, we'll draw from the boneyard for player 2. Bada bing, bada boom. Alright, cool. And we'll quit. So now we've implemented the... whatchamacallit? the doubles. So if it's a double, then we can then play an additional tile or on another eligible train. And if you don't have any additional tile, draw a tile and play it if you can. Alright. So, alright, cool. So now we have that. So I think what I also want to do, because I've been working a lot on just the play function. We have an easy way for draw. So if we're gonna draw, then we need to display that draw. So we get a random domino from the boneyard, and then I guess what we will do is we will ask, or we will show the domino, and we will ask, is this the domino, or would you like to play this domino? Alright, so yeah, so we'll draw it, we'll add it to the hand, and then we will print the domino. So draws N1, going off of the format, draws N2, and there we go. Okay, so now we're gonna say, well, we'll say this is your domino. This is your domino. And then we will then ask, would you like to play this domino, yes or no? We'll say, where the fuck is it? God damn it. Here it is. Alright. So we'll say play domino, question mark. Or we'll play drawn domino, yes or no. And we will determine if it's a yes or no. If f dot equals yes, then we're going to initiate, then we're going to initiate play functions, else, yeah, we'll just, otherwise, we're just going to assume that they don't want to play it, and we'll just, well, we just won't do anything. We only want to do stuff if it's yes. So, if it's yes, then I gotta think about this. Okay, no, I have a better idea. Instead of, we will need the else. So if they don't want to play it, then we add it to the current player's hand, right? Otherwise, we don't want to add it to the hand prematurely. So if it's a yes, then what we will do is play that domino. And we will need to... did we already delete it? I forgot to get random. We never delete it from the boneyard, do we? So, okay. Alright, so then this is what I want to do then, since I don't have this implemented. So the domino, oh fuck. The domino in question is based on this. However, we also want to delete it. So okay, well, I guess we'll also have to do the we'll also have to get this. So we'll have the random integer be placed in here, and so that we have a predetermined, so that we know what the random integer is, because we need to delete it from the list. And then we have our domino, which is selected, and then what we want to do is we want to take the current list that we just took it from, and we're gonna remove it based on the index, and the index is gonna be based on the random. And then we're gonna return our selected. All right, modified, beautiful, sexy. I love it. All right. So we get the random domino. It deletes it from the boneyard. We then draw it. We now have this domino called draw, or our drawn domino. And if we choose to play it, then we need to add it to the train in question. So I really hate to implement this again. I don't like having this duplicate code. Alright. I'm thinking. And new plan. Instead of having all this code, which is absolutely troublesome, especially for the fact that I have to actually reuse that for placing the train, I will make this into a function. Should have done it earlier? Probably. But we're doing it now. So this should be pretty simple. This returns nothing, so and we're just going to save place domino in train. Very, very simple. And what we want to take is we might need to make 2 of these. Fuck, man. That's the problem. The fact that I have a human and computer class, that's really gonna fuck me up because I'm doing double the work. If I made them using an inheritance class like player, I'm pretty sure I would not be running into this problem. Anyways, we're gonna press forward. Place domino and train. Obviously, we're going to have to designate this as H. So we know that we're dealing with a human play. We will be taking in an array list based on humans. And this will be called human. Well, again, we call this HM. And we then also want to take in... We take in our selected domino. So we take in our selected domino. And then what we also want to take in is our selected train. And we'll use the same names just because we're going to be changing the actual, or well, we keep the same names because we're going to want to pass by reference. And so, yeah. So we don't need to make copies based on this, on the way that we are doing this. Okay. So now I should just be able to go take all this Right, wait. Where does it? Up to this line. Yeah. I should just be able to take all this and place it right here. Alright. And I'll change this to players. There we go. So variable selector train is already defined in this scope. Oh, okay, yeah, that's right. We determined the selector train based on that. So I don't need to take in a selector train. Okay. And yeah, so then we have this. So if we want to implement it, place domino, and we take, what is it? HM players, and we take the selected domino. Okay. So now, well, that's going to be a problem, isn't it? Rerunning this. Alright. So let's see here. Okay, I can actually fix this problem. Instead of having all of these, I can change this to a boolean. And whenever we encounter something that is false, we will return false. So I will need to mark this. If for any reason we need to restart the input, we will return false, because that means that we can't, returning false means that we can't place a domino in train, so we need to restart, and that would make this a lot easier. So what we do is we just change this to returning false. All these. So we return false. What we would, yeah, that's what we do. And we return false here. Return false. We return false. Bada bing, bada boom, bada bing. If all goes right, then we return true. So we won't need to do anything else. Very easy, very simple, elegant maybe. Oh yeah, that's right. We have this is double. I guess we could pass it on. We'll pass it on. We'll pass on the is double as well. There we go. Perfect. So now what we wanted, so now, and here's the magic, right? Oh fuck. If all this, if this returns, that's what I'll do. Alright, if this returns false, right? Having the not there means that if this is false. Well, I could get fancy, but I want to make sure that this works. Just because I doubt. If this is false, right? Then what do we know? We need to restart it. So, we call input. And we take back everything. Very simple. Otherwise, we're not going to do anything. And that is how we minimize all that code. All that obnoxious code. Oh, I am going to take an HM, aren't I? What do I have? What did I have HM as? HM is the human, that's right. The human in question. And then we have the human players. So I guess I also need to take in human. Again, we're gonna pass by reference just because it just, I think that's the call in this situation. Alright. And then T. Well, T has been predetermined, right? That's the string. Do I also need to pass in T? That'd be stupid if I do. I guess I do. Alright. A lot of things. I think I'll find a way to optimize it a bit better later. But we'll take in T as well. Just because. Alright. Do I also need to take in D? What the fuck? Oh, yeah, that's right, because that's the domino placement. For fuck's sake. Well, I'll take in D as well. Fuck me. String D. There we go. And we take in D. There we go. So now we've minimized everything here. Are we gonna have to have a double of it? Yeah. Unfortunate because of the way the computer's built. But we will get to that later. I'm not gonna bother with the fucking computer knowledge, whatever. Anyways, what was the whole purpose of this? Oh yeah, that's right. The whole purpose of this was to implement D. So okay, so back to the double. So we drawn this domino from the boneyard. And we want to use this domino on a train. Well, we need to ask the questions. Which train? Fuck. Okay. Let's see. Yeah. This is all, it's all coming together now. We'll just say this. So we've determined if it's yes, and then we ask it, the person, which train? Again, similar thing here, right? And yeah, because our place domino also has the flip function. Yes. I knew what I was doing. I had moments of doubts, but now it's back. So yes. So here, based on the train, we'll do this. Our selected domino in this case is draw. Do we need D in this case? What is D? Oh yeah, that's the number, right? Shit. Okay, let me think. So we draw it. Do you want to play the drawn domino? Yes or no? We want to play the drawn domino. We want to play the drawn domino. Here's the train that I will tell you. And in this case, D references this to where we remove it from the hand. Well, now I see a problem, right? Because this isn't in the person's hand, isn't it? So what do we want to do? That's the problem, isn't it? Because in this code, right, we're removing this from the hand specifically. Based on the player's train, we're gonna determine which human, and then we remove it from their hand, right? Oh, I got it. Okay, I know what to do. Instead of taking the string, right, we're gonna take the int of it. Well, this is what we'll do, and this is amazing. Well, actually, instead of just having duplicate code like this, we will do something magical. You guys ready for it? Because I certainly am. Bam! So we parse D already. So we're taking in an integer, and because we're taking in an integer, what we can do, so maybe my assumption was wrong at this point with the adding it to the hand. We will add it to the hand prematurely, right? The whole point of me not wanting to add it to the hand prematurely was because it just would have been bad. But since we're adding it to the hand prior, what we can do is this. We know that when we add something to an array list, it's going to be added to the very end. So, since we add it to this based on our human, we're going to then say, we're going to take the hand size -1, and I think that gives us the last element in the hand array, and that gives us what D is, and that's what this was supposed to be. It's removing, this right here is supposed to remove the index at which we got the domino, and if we're adding the domino to the end, in this instance, because we're drawing, we're just removing the end. We're adding it to the hand, then we're removing it again. So here we could just replace all these to D. And that simplifies it a lot for us. And we make it work. Bam! Bam! Awesome. Okay, cool. So now I think our draw is really good. So yeah, so we place the domino train. If it returns false in any way, then we restart input. I mean, yeah, I could make it more. I can make it like, oh yeah, restart the draw section. But I really cannot be bothered. There's just so much work just for this one little functionality. And I mean, this works enough. It's decent. So, is it gonna be tedious if someone messes up? Yeah, it is. But like, come on. Like, how are you gonna it's really hard for, unless you're deliberately messing up. Like, and if you, let's say you do mess up, right, once, it's a little tedious, but sure, like, it's okay. It'll be okay. So back on track. What do we have? We have the draw. We draw the train. We put the train in. We pass it down. It works. I guess we should test it out, right? So we will test this out just to make sure our game still runs. 2 humans, 0. We're gonna draw. Alright, we drawed an 8 and a 9. Do we want to play this? we're going to say in this case, yes, we're going to play it on ours. And no, we don't want to flip. It says yes in this instance because I haven't really, the centered is all wrong, but it should be fine. Oh, actually, I think I need to implement something. I need to implement the actual center domino. Fuck. Alright, so I draw on a 4 and 5. I can't play that, so I will say no. Alright. And we quit. Alright, cool. It works. It works. Our implementation works. And that's all I want from it. As far as the computer stuff goes, we're not going to deal with that. All we're doing right now is the rules. Once we get the rules set in stone, making the computer is going to be 10 times easier. Because then we just need to run the methods to compare the rules, and then we're easy. And then we're done. It's simple. So we have draw, we have play. If we draw a double, then we can play it or not. We have these systems in check now. Of this voice crack, the is double right here determines that if we want to play it. If it's a double, then yes. And then what we're going to do is, yeah, we end up restarting it. Very simple. Okay. Next thing, an open double. If after a player's turn, okay. Oh, actually, there's still a couple more things we got to do, right? We need to center that. We actually have to make the domino a center domino. If you do not have an additional tile to play, draw a tile, and if you can't play the additional tile, place your marker on your personal train. Play then passes to the next player. So that's the thing here, right? The marker. Place the marker. So according to this, if you are still unable to play after drawing a tile, you place a marker on your domino set. On your personal train, or your personal train near the end, or where the train will begin. If it hasn't yet been started, your turn then ends, and the play goes to the next player. A marker on a train signifies if the train is eligible to be played on by the other players, while there is a marker on your train. Oh, fuck. Okay. Another condition, right, to the is playable stuff. Alright. Okay, let me think about this. So, alright, so first things first, we need to add this new element, right? We're getting rid of this. I have not been using them. It's a boolean, right? So, and this is, we're going to call this the marker. Predetermined, it's going to be false. All of them will be false until proven. So we set it to false. And so, let's see. So what I want to do then is, okay, let me think. When we display the board and we display the person's name, we also want to display their boolean. So if it's a marker or not. Okay. I guess I gotta encapsulate this. All right. God damn it. All right. Oh, God. Okay. There we go. What is this? C. We gotta add marker to the computer as well. So public boolean, I'm gonna call this marker, is equal to false, right? So this condition, right? This condition is going to it's going to depend. So it's like, okay, so maybe that makes my is playable a lot better. Right? So we need to determine if it's okay, I gotta think here. I gotta look at this shit. So what makes a train eligible? It is my check train, right? So this check train, this returns true or false. So I think what I want to do here is, okay, so I'm gonna have to add it here, aren't I? Okay. So so if the train in question is empty and the train is not equal to our train, then we can't play it. However, that's not technically the case, right? That's not a condition that will be applied. So what we want to do, if the humans marker, well, because let's say player 1 is false. So maybe what I want to do is actually determine the true statement of this, right? So let's see. So if the quote-unquote humans marker in question is equal to false, right? And this statement is the same, right? So, and the train that we're placing it is our train. We don't need permission to place it on our train. I think I might need, okay, yeah. So if we are false, no, because that's not a valid reason, because we can be false or true and still play on ours. So maybe this one is best explained as such. If the train is empty and the train is equal to us, then we want to return true. Otherwise, we return this. God damn it. I want to get rid of this. So, okay, so this if statement will determine... Wow, well, fuck. Okay, because then we run into a problem of, okay, we place a domino on our train. Right, we place a domino on our train, but then if we want to place another domino on top of our train, we can't do that because of this and. But I can't make this an or statement either because, say the train that we're trying to place is player 2, but we're player 1 and theirs is empty. But it's not ours, so that doesn't satisfy any of the conditions. Alright. I think I actually know. I'll have to break this up. Right? So if if the train that we're placing it on ours, regardless if our marker is true or false, we're going to return true. That is a valid play for our train. Else if, whatever. If the train, right? God damn it. If the trains okay, so that's so that if the train in question's marker is true, is equal to true, then what we also want to do is return true. So what do we know? So if we check for this human, right? And we're player 1, we're placing it on player 1's train. It will pass this because we are the same person. The human train and the human in question, or the human train in question and us are the same. We should pass true. However, let's say I'm player 1 wanting it to place on player 2. This will not pass, but this will if their marker is true. And that means we have a valid play. And their marker cannot be true unless we set it to true after they can't play anything. But then we can still play on an open space, so we don't really need to know if it's empty or not. We can still play. Otherwise, we're going to say the train's not open. Alright, that's it. Let's see, so okay. Alright, so we got the marker. We still need to place the marker, so we only place the marker if we cannot play the tile. So here so if it is a yes, then if we can play the domino, then we will play it. Otherwise, if we can't play the domino, what we're going to do is we're going to set the current person in question is going to be equal to true. Oh, fuck. Okay. A marker on your train remains there until you play on your personal train during a subsequent turn. So we have this marker being set to true if we cannot play a domino. But let's say we do play it on our train, right? So then that will reside in this. If it is on our train and we can play it, yeah. And then we want to set the third marker to false. Very simple. That's only if it is ours and we played it on ours. Alright, nice. Okay, cool. Alright. Okay, so let's see. So it's only an hour, but I will wrap things up here. So what do we do in this hour? Well, we determined when we play a double, you must also play an additional tile. So we implemented this rule of playing a double. We still need to implement the open double, but we also implemented the marker and removing of the marker. So I think next time, or well, I'll definitely be working on this later tonight again. Let's see though. The playing of the double we've implemented. Play that passes to the next player. An open double. I guess we can implement that now. So if after, so let's see, so what does it say here? If after a player's turn is completed, the double is opened, or no, the double is open, not played on, all other trains become ineligible for all players until a player can play on the open double, which is to say the double must first be satisfied or closed before any other trains, marked or unmarked, can be played on. If subsequent players cannot play on the double after drawing, they must place a marker on their personal trains. Once a marker has satisfied or been played on the double, all players are then free to play on any eligible train. Okay, well that's fucked. Okay, so, how are we gonna do this with what we have so far? What do we have so far? That's the question, right? So, we can place the markers, and we place the markers here based on our human player. So I think what I then have right is a generalized statement, I guess another general variable that determines whether if we have an open double or not. If the open double is true, then everything goes. It doesn't matter if it's mine or yours. All the trains will technically you can't play on any train unless it is the train of the doubles. Okay, so that's the hard part, right? If I have a domino on player 1's train and I'm player 2, but the double is an open double, I can't play on any other train regardless of their marker. I can only play on player 1. Okay. Oh, the music stopped. Let's see, where's more copyright-free music? There we go. Let's see. Alright. I have an idea. Maybe it's bad, maybe it's good. We don't know yet. Alright, but we have this marker. How about we indicate which player has the open double? And if we can indicate which player has the open double, we can then only allow that player's train to be played. So easy, simple. We will then make, what is it? So well, this is its own human, right? Can I actually call my own? Yeah, because this is just a holder. Yeah, so then we'll just say, we'll call this the open double player, right? And obviously this will be set to null because we won't be assigning it until we have a human player, right? So all right, so we have this. How do we implement it? So we have the parameters set already to determine if we are dealing with a double, which is here. So if we are dealing with a double and it is true, and we determine the domino is playable on the selected train of the selected domino, we then add it to the train. We then need to set or that we then call false, right? Because then we need to say play Alright, so is double is true in this case. And let's say, for instance, it is a double, we return false, right? And as I explained before, when we return false, right, we then reinitiate our method to where we get the person's input. Because if we play a double, we can play another domino. And we have these options, right? So we can either play the domino. In that case, we get rid of the option of the open double. However, if we decide to draw from the boneyard and we decide to not play it, then then we need a condition in this area. So if is double is true still, right? If it's true, meaning that we haven't set it to false, where do I set mine to false? Where have I set this to false? Damn it, why are people Snapchatting? Alright. Crap, what was I thinking? I don't think I have a condition that sets it back to false, don't I? Shit. Okay, well, no matter. What we'll do then... So place the domino on the train. If it is a yes, then we do all this stuff. If we can place the domino, then we do these series of steps. So okay, so all right. So every time that we succeed, right? And placing a domino on the train, we're going to want to set our is double back to false if it is true. And we assume that it is. Right. Why is it, Oh, I'll just move it up here. What the? It's assigned to, but it's never used, yeah. Maybe not there. That's not where I need it. The value false assigned to is double is never used. Okay. Yeah. This is what I want then. Because if we play a domino, then we want this, yeah. Because if we play a domino, then and it is double. Well, that doesn't do us anything, doesn't it? No. Because let's say we do play the. Fuck. Okay, so let's say we do have a domino that we want to play, and we do play it. We place domino and train of a human, right? And we place the train and the human train. We've determined prior that if it is a double or not, based on if the left and right are the same. And if that's true, then we use the sequence. We select the train, we add it, and then we return false, because what we need to do is then initiate the next sequence of events. And let's say we end up playing again, right? We end up playing the domino in question. If we play the If we play the domino in question, we do the exact same thing. We end up doing the is domino. Oh, I see it. We're getting into a loop, aren't we? Because we haven't changed is double prior. It's still going to be true. So if we run this again, this method, it's gonna keep hitting this if statement, aren't we? Shit. Well, that's the thing, right? Because it's like if we how do we bypass this? If we have a double, but then we initiate the same thing again, we want the double to stay true. How do we explain this? It's like we know that we have a double. If we play a domino, if double is true, then we should change it to false. This is tricky. This is tricky. It's all about where do I change it to false. Maybe this would suffice? I'm not sure. It's this that's the problem. God. Gosh dang it. We're gonna keep hitting this is double, and we're just gonna keep repeating the same cycle. Shit. Fuck, I am out. I don't know what to do. We determine it here. Shit. With the way that we have things going. God damn it, he keeps fucking texting. I'm really at a roadblock, aren't I? I think I'm actually just getting cucked by my design right now. How do I, in a way, know that I'm already in a double state? Oh, wait. I think I know. I think I know. And it had to do with what I had earlier. I just didn't put two and two together. I have this open doubles player, right? I will assign where I found the double. If I have a double, I will assign it here. Whoever and whenever I found this double, the open doubles player would be equal to the human, right? So this will always be overwritten. I don't actually have to get rid of them. Or I can just technically set it back to null. But anyways, we have the open double player. We know is double is true. We then run it again. Before we play, right here, if our place domino train is equal to false, and, well, no, shit. Fuck, man. Shit. Because, damn it, because all of our play stuff is coming from here. All of the play stuff is coming from here, and this is double is always going to catch. But let's say I want to play. I need to sense that if it's already my second time going around, you know? If it's the second loop. I could just set a loop integer or something. At least, because then if I know that this isn't my first time around for this specific person. Oh, but that's just so much, isn't it? Oh, do I need to do that? I was hoping to utilize. Well, no, I still am going to be utilizing it. I just can't implement it yet. I need to find a way to get around this is doubles. Okay. Alright. Well, this is what I'll do then. Oh my gosh, and this involves another argument. So many. Oh my goodness. And, we'll call this valid, right? We'll call this, it's like a valid bit, I guess. So... Oh, wait! Oh! I'm a fucking idiot! Oh, no! Well, hold on, I'm also a genius. I don't need to. Whenever we restart this input, we automatically set it back to false. And if the domino that we select is in question, right? Then it's only it's not going to do it. Man, I'm ahead of the game. Oh my gosh, all of this thinking and I already done it. I've just been a pro my whole life, apparently. Damn. Okay. So that was a problem that was already solved. So I don't need to worry about setting is double to false. It's going to be setting it to false automatically each time. Bam. I can get rid of this. Okay. So now I can focus on the real thing, which is making it so that only the marked double person is played. So we have this person, right? So what we want to do, I think it needs to be in the, because we want to draw, then we have to place the domino. If we place the domino, we have to check if it's a train. So everything resides in our check train. So what do we want in this area? if the train is the same, then we're going to say yes. If the marker is true, then we're going to say yes. If on the off chance that we experience an open double, then we say if the human train in question is equal to the human double, if the human train in question, or we're basically going to do the same thing, right? If the name is equal to the name of our, what do we call it? The open doubles player. If it's equal to the open doubles player's name. Then we know, what do we know? We know that we can then play on it. Otherwise, we're going to return false. Or the train, we say that train is not open. Yeah, please try again. Okay. And let's say we do play on this open player, right? We play on the open double player, and before we return true, we set open double player equal to null. We set it back to null. That way, that if we come across another doubles, then it would just, this takes care of all our problems. Alright, that was actually very simple. And it didn't need to be as hard as I made it out to be, apparently. But that's coding. So let's try this out, I guess. I don't know if I'm going to be able to implement. I should have made test cases. You know, that would have been the smart thing to do. However, I am lazy. Okay. So we'll do the first thing, right? And that is, again, we still need to implement the center double. So we can play, at this point in time, we can place any domino we want for our train. So, do we have a double? 0, 1. Yeah, we do. 0, 1, 2. Okay. We want to place a second domino in our first train. Double was played, play another domino. Alright. So now let's draw from the boneyard. Do you want to play this? No, I do not. I guess I'll indicate something about there being an open double on the board. But let's say I want to play a domino. I'm not going to even look, but I'm going to try, say I'm player 2 right now. I'm going to try to play a domino on my train. This should not pass because I have condition. Sorry, player does not exist. Okay, wait, where is that coming from? Oh, it's this. God damn it. Shit. Well, restart it, I guess. Well, that's why we test these things. Back to it. I'm player 1 again. Oh, look at that. I have a double on the first domino. I'm getting really lucky. Which domino? 0. Which train? 1. Double has been played. Play another domino. Oh, I definitely will. I'll draw. And I will say no, I do not want to play. And then on player 2, I would like to play a domino, sir. Which domino? I'll say this one. Which train? My train, please. Do I want to flip? No, I would not like to flip. Alright, looks like I was able to play. That should not have happened. So there's a reasonable explanation for this, and that is this. The fact that I have this checking it first. So this is what I want to do. By doing it this way, it's going to check the double first, and then it's going to check if it's the same players, and then if not, we check the marker. Otherwise, we do this. All right, easy. We keep moving. I guess I could combine this into like an OR statement, but fuck it, I don't care. All right, relaunch this bad boy. Double 12, 0, 0, 1, 2, 3. We have a double 9. So we're gonna play domino. We're gonna play the third one. We're gonna play on our train. Of course, double's been played. Draw. No. Player's 2's turn. I will play a domino. I don't care which one. Train 1. Oh no, train 2. I get a no pointer exception. Okay. Well, let's see what's happened here. Line 199. Oh, so we have a null. Okay. So the only explanation for this null happening could be here. We set it equal to our human, in which I assumed everything would be copied over. But we're getting null because I didn't do this. New human, and then we set it equal to HM. Yeah, that would do it. 5th time's a charm, right? Let's see here. So far I've been getting kind of lucky with my doubles. 0, 1, 2, 3, 4, 5. Double 9s. Domino 5. Train 1. Doubles been played, I guess. No, I do not want to play. Alright. I would like to play double. It'll be domino 2, and I want to play it on my train as player 2. Wait, did I also play a double? Zero, 1, oh no, I played a double. Oh no. That's not supposed to happen. Alright, well, at least we know that I can't play it. I played a double on a double, and that should not have passed. Well, that one's just unfortunate actually, because no, that just shouldn't pass at all. Oh, I see. Here's the problem, right? So this ends up being false. and because it's false, it moves on to the next. So what I want to do is, if this is false, if these are false, then we return false. We also need to determine if it's not. God damn it. Because we might get another null pointer exception by doing this. So we want to return false either. Ah, fuck, damn. Let's see. Open double player. Okay, so I'm thinking, and I think what I want to do is this. So if our open double player is not null and the train in question is not the train that we want, is not the train of the doubles or the double train, then we return false. Otherwise, we're just gonna go through this, and at the very end, in each one of these, we're gonna be setting that to null. And so hopefully this works. Two human players, 0 computer. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. Play domino 9. Our train. Draw. No. We will play domino. Domino 0 on turn 2. And it still should not have went through. Alright, I'm gonna figure this out. I get no pointer. Oh, that'll do it. I still keep getting no pointer. Look at this. Zero, 1, 2. I keep getting no pointer. Fuck. I'm gonna have to figure this out later. Anyways, that's all I got for tonight. I will catch you guys next